robot tries to move to the bottom right corner, that is grid m-1 and grid n-1 is here. The robot can only move either down or right at any point in a time. Given the two integer m and n, return the number of possible unique paths that the robot can take to reach the bottom right corner. The test cases are generated so that answer will be less than or equal to 2 into 10 to the power 9. Okay. So we have given a robot, and we have to find the number of unique paths so that they can reach the finished point. The robot can move only right or and down. So let's see how we can solve this problem. So for solving this problem, we have let's make space. We have to go from 0, 0 to m minus 1, n minus 1. Okay. So we have to find all the unique paths so that we can reach the finish point. So whenever we have we have to find all the unique paths. So whenever we have to find all the subsequences, all the paths, for that cases we use recursion. Okay. So when we write our recursion function like f of I comma j, it means we have to find number of unique way from 0, 0 to I comma j. Okay. So for writing our recursion function, first we have to declare what is the base cases for the recursion function. So if I is equal to 0 and j is equal to 0, so for the recursion we always use the bottom to top approach. Like first we initialize the our indexes with m minus 1 and n minus 1, and then we decrease our indexes, and we reach to the 0, 0. We cannot go from 0 in the recursion. We are not going from 0, 0 to n minus 1 and m minus 1. We are doing opposite. We are going from n minus 1 n comma 1 and n minus 1 and m minus 1 to 0, 0. So if I is equal to 0 and j is equal to 0, if I is equal to 0, j is equal to 0 and j is equal to 0, it means we reach to the destination. So for that cases we return 1, means we reached. Okay. And so when we have to go to we have here and we have to go here, so we can move upward and left. So for up we call for I minus 1 up, we have to go for up. So row will decrease and the column will be fixed j. So this parameter is row and this parameter is column. So when we go up, row will be decreased by 1 and j will remain still, and when we are going left, then when we going left, then row will still same and j will be decreased by 1. Okay. And we return we can choose this path or choose this path. Okay. And by choosing both path, we have to find the total number of unique paths. By choosing this, there may be multiple paths like this, this, by choosing this and this and this. So we return the sum of both up plus left. This is our recursive function, recursive calls that. And let's say we are if I is equal to 0 and is equal to 0, return 0. Okay. Okay. If our I will become 0, like when we are here and we call for up, we call like we are at here and we call for up, it is fi minus 1. So we come here, so there is no path for here. So if I is less than or equal to 0, say we return 0, there is no path. And if j is less than 0, so for that case we also return 0, because if we are here and we call for left, so it goes for out of the array, so there is no path for us, return 0. This is our base cases and this is our recursive calls. Let's write our recursive function. Okay. So we write a solve function, and in this we pass our m-1 and n-1. Remember this is given int m command, not n command. Okay, and we return this, and int solve int I int j, and as we discuss our base cases, if I is equal to 0 and j is equal to 0, it means we reach our destination, so we return 1. And if by any chance I will be 0 or j will be 0, so we cannot get any pass, and we write our recursive calls up is equal to solve, row will be decreased by 1 and column will be same, and left solve, our row will be still same and column will be decreased by 1. Declare this, and that is equal to 0, int left is equal to 0, and we return up plus left. It's all okay. So let's run this. Okay, this cases will be run. Now submit this. I think we going to get a TLD, time limit exceeded. Okay, so this is our recursion approach. So now we optimize this problem and write the DP approach. Before moving to DP, we first see that there is any overlapping subproblems or not. If there is no overlapping subproblem, so we cannot write DP for this problem. So for seeing the analyzing the overlapping subproblem, we try run our solution and see if there is any overlapping subproblem exist or not. Okay, let's run this problem for f of 2 comma 2. Okay, so for f comma 2 comma 2, f2 comma 2, it not goes that and that, so it calls for up solve I minus 1, and yes, it calls for it calls for I have a pen and paper, so I can explain much better, but no problem. We going to call this function, so 1 comma 2, and further it also going to call this function, that is 2 comma 1. Okay, and furthermore 1 comma 2 will be called, so it not going in any of these conditions, and it call further f. We are going for up, so it's more decreased, and it's the same, and it call for further same this 1 comma 1, and further I is equal to 0 and j is equal to 2. So it call for f minus 1 comma 2 and f 0 comma 1. So for minus 1 it will return 0, okay. For 0 it will become 0, and 0 1 be called, 0 1 called, and it goes further down, and it call for f of minus 1 comma 1 comma 1, and further it call for 0 comma 0, and it will for minus 1 comma it will be 0, and for 0 0 it will return 1. Okay, and furthermore this call will be completed, and it will return sum of both this and this. This is up and this is left, so this will be this is equal to 1, and this sum will be equal to 1. Yeah, equal to 1. Okay, so f of 02 will be completed, and f11 will be called. For f11 f11, when f11 will be called, so we can see it. So we got 0 comma 1, and also we going to get 1 comma 0. Okay, and when f of 01 is already calculated, so we can see here there is a overlapping some problems, so it will become equal to 1, and when f of 1 comma 0 will called, f of 1 of 0 is never called here, so we calculate this. It will call for 0 comma 0, and further f of 1 comma minus 1, so it will become 0, and it will become 1 because it f comma 0 will reach to the destination, so it will sum up both and it will return 1, and this is 1, and f11 will become 2. So we can see that there is overlapping subproblems f of 01, f of 01. There is also many overlapping subproblems we can see, so we can use dp. That's the summary of this dry run. So we make a vector of vector int dp, and we declare up size of m plus 1 comma vector int of size n plus 1 comma minus 1. We always declare dp of size of 1 extra, because there may be chances of extra indexes for edge caches. So we pass our dp inside our Pikachu functions, like we can pass here dp comma dp, and we can pass with call variables, so no extra copy will be generated for dp. And furthermore we write here condition for dp of I comma j not equal to -1, so we return our dp I comma j, and we also store in our dp of I comma j is equal to dp of I comma left, and we return dp of I comma j. Okay, and we also pass it here dp and also dp. Is there some problem? Where is all green? Okay, that's my boy. So I think we write our dp code and it will be run smoothly. Let's run the test cases. Okay, all the test cases will be run, and now submit this problem. I think we solve this one. Boom. So this is the solution of dp approach. Now let's move to the another problem. Okay, so third problem is unique paths 2. This is the advanced version of previous question. Let's read this problem. We have to given m cross an integer array grid, that's previous one. All there is robot initially located at top left corner. The robot tries to move to the bottom right corner. The robot can only move either down or right at any point in time. And obstacle and space are marked as 1 or 0 respectively in grid. A path that the robot takes cannot include any square, that is an obstacle. This is the extra point. Okay. Return the number of possible unique paths that the robot can take to reach the bottom right corner. Okay. Okay, what does that mean? An obstacle and space are marked as 1, marked as 1 or 0 respectively in grid. A path that the robot takes cannot include any square, that is obstacles. What do you mean? 0,0,0,0,0,0,0,0. There is no one obstacle in the middle of the 3x3 grid. Okay, there are two ways. Okay, 0,0,0,0,0,0,0,0, 0,1. Okay, I think the problem is there is a slight change the problem from the previous one. If if grade of I comma j is equal to 1, that means there is an obstacle. We cannot take that part, like when we are going like this and this, we cannot go from that to that. For in previous question we can go from that to that to that and reach to destination, but we cannot choose that path. So our paths will be decreased, so we have to return the paths, total number of paths. So let's solve this. We use our previous question. So we have only one extra case to include in our previous question. Like we will copy this problem. Copy this is we are given m cross n integer. Let's see. Copy this. Copy. Paste and copy and paste. So we have not given m command, so int m बराबर og not size, because we have given the m cross n matrix, not the n cross m matrix. So og dot size will be m, and int n is equal to og of 0 dot size. Okay. the constraints. Size of OG will be m, okay, and okay 1, and we have to write an extra condition here. If what we have passed our OG here in our function OG, we can copy that. You will see we can put it here. Okay, if I is greater than 0 and then j is greater than 0 and then OG of I comma j is equal to 1. Okay, when is equal to 1, so there is no path, so we return 0. There is no further path, we cannot go further, so for that we return 0. And let's see it is done or not. OG, run this. I think this will run. Boom. Now submit this problem. Arey, yeah. Why? This is the size. What is the size of this? Size will be 1. Okay, for 1. I think we have to write this condition above, because I is equal to 0, j is equal to 0, it return 1. That if it is called earlier this condition, so this will not arises. Let's run this. Yeah. Yes. Now I think problem is solved. Boom. Okay, so this problem is solved. Let's see another problem. Okay.